Hello everyone, welcome back to our videos in Bazara Aviation Academy. Today inshallah our video it will be about physics chapter 2 general book. Before we start our class today, I will answer the last homework if you remember it. The homework was which physical state of matter is compressed and incompressed. The answer is solid and liquid are incompressed and gas is compressed. Now, before we start our class, I hope by the end of this video, all the students can able to understand the meaning of the word and its formula, understand the meaning of power and its formula, understand the meaning of specific gravity and its formula, and can understand the types of lever and the function of lever and its formula, can understand the function of inclined plane and its formula, can understand the function of the pulleys and their types, and also understand the meaning of gears and their types, and understand the meaning of the stress and its type, and the last one can understand the meaning of motion and its laws and its types. Work. The work is the product of force and displacement. How that's come? For example, if we have here a ball, and this ball will move from here to this area by a force that will this ball move from this area until arrive to this area. Here we have a work that done. Here we have the definition of the work. The work is the force that applied to an object and the object moves. We have the formula that used for calculate the work, and the formula is equal to the force multiply the distance. Now what's the unit of work? The unit of work on the metric system is the joule. How that's come? Here when we back to our formula, we will find the unit of force is Newton and the unit of distance is meter. So meter multiply Newton, it will give us the joule, and that's on the metric system. What about an English system? An English system is foot bound or inch bound. We will focus here when we convert from foot bound to inch bound. We will note that 1 foot bound is equal to 12 inch bound. So when you will convert from foot bound, you have to multiply by 12 inch. Now we have an example. If an engine weighing 400 pounds is lifted 10 feet, how much work that done? What we will do now, we will have a given, and our given it will be the force equal to 4 pounds, and here we have our distance, it will be 10 feet. Now we have to apply our formula. The formula said work is equal to force multiply distance, equal to our force is 4 pounds or 400 pounds multiply our distance, it will be 10 feet, equal to 4,000. 4,000 what? If we back here, we have pound, so it will be 4,000 foot pound or feet pound. That's all things about the work. Power is the rate of doing work. And our power is divided into electrical power and mechanical power. And when we want to calculate our power, we need to find the work and the time. So here we have our formula for that used to find the power. The power is equal to the work divided to the time. Or we can say that is the force multiplied distance divided to the time. Force multiplied distance is the formula of the work. The unit of the power. We have in the metric system joule per second. The joule is the unit that used for the work, and the second is the unit that used for the time. Also, in the English system, the unit of the power is foot pound per second. Like the metric system, the foot pound is the unit of the work, and the second is the unit of the time. We have another unit for the power, and it calls horsepower. The horsepower is used when you want to find the power of engine or motor. And here we have two formulas that used. The first formula, horsepower is equal to work divided 33,000 multiply the time. And the second one, horsepower equal to work divided 550 multiply time. When I will use this and when I will use this. If you have an equation and you find that the time in minute, we have the time in minute. You will use the first formula. Horsepower is equal to work divided 330,000 multiply the time. But if we have our time in second, you will use the another formula. Horsepower equal to work divided 550 multiply the time. How can this come? We have here an example. Find the horsepower required to rise a 12,000 pound airplane 6 feet in 1/2 minute. Before we start answering, we have a given. What's our given? The first one, it will be the weight or the force. After that, we have the distance, and here we have the time. So here you will say the weight of the airplane or the force is equal to 12,000 pound, and here we have the distance equal to 6 feet. After that, we have the time, and it's equal to 1 minute. Focus, guys, here. When we have to find the power, we have to find before that the time, and it's important for us. Now we will write our formula. Our formula is the power or our horsepower, horsepower equal to, the first thing is the work, and divided to 33,000 multiply the time. You will ask why I use 33,000. Because here we have minute. The time is in minute, not in second. If in second, we will use this formula. Work divided to 550 multiply the time. Here, we don't have our works. So we will use this. We will find the work at the first. And we will set this. The work is the force multiply the distance. Now we will do this. Horsepower equal to, our force is 12,000 multiply the distance 6 feet divided 33,000 multiply our time, it's 100. Now you have to use your calculators and we will find that. 12,000 multiply 6, it's equal to 72,000 divided 33 multiply 1.5. We will find that it's equal to 6,500. Now you will divide this by using the calculator or by using your hand. If you will use like this, you will omit that to make it easier for you. We will find that our horsepower is equal to 4.36, and that's how to find our horsepower and how to use these two formulas. The second type of power is the electric power, and the electric power is equal to the voltage multiplied the current. How that's come? If you take a lamp of your home, you will find that the power is equal to 12, maybe 15 watt. That means the power of this lamp is 15 or 12 watt. The unit that used for the electric power is the watt. You will study more and more details about the electric power, inshallah, in chapter 3 in electricity. Now we will talk about the mechanical advantage. The mechanical advantage is a tool that used for increase the amount of force that applied to an object. We have 4 types of tools. The first type, the lever. The second is inclined plane. The third is called pulley. And the last one, it's the gears. In this figure, we have the first type of mechanical advantage devices, and it's called levers. The levers is a device used to gain a mechanical advantages, and our lever consists of 3 components. The first component is the effort, the second fulcrum, and the last component is the load. Our levers have 3 types or 3 classes. What are these classes? As we see here in the second figure, we have 3 classes of levers. This is the first class, this is the second class, and this our first class, this is the second class, and third class. How can we make distinguish between the 3 types or 3 classes of levers? By the location of our components. Here, when we say the first type or the first class of levers, we have load, fulcrum, and effort, and they are in their locations. Fulcrum, effort, and load. When we back here, we will say the second type here. We say the location of effort is differ from the class 1, and the location of load is differ from number 1, and also the location of fulcrum. And the third type, we will see the location of our load is differ from the second type and the first type, and the effort has a location also differ from the first one and the second class. Also, they have the same location of the fulcrum just between the second class and the third class. Now, after we finish this and know the types and the component of levers, we will have equations and how to answer the equations and issues that related to the levers.
this lever. In which class this lever? Of course it will be in the first class, because here we have our load, here we have our fulcrum, and here we have our effort. Before we know the mechanical advantage or how to calculate the mechanical advantage of lever, we will know how to make the lever balance. We will make the lever balance by understanding the moment. What's the moment? The moment, it's the weight multiply the arm. That's our moment. And here we have A and have A small. The A here, it's the load or the weight, and the A small, it's the arm of A or of the load. And here we have the weight B and its arm, the B small. When we see here, this is weighed 10 pounds, and the arm of it, it's 6 feet. We will write it here, 6 feet. And here the weight of B is 10, and the arm of B is 6. We will focus in this. Here we have our fulcrum. You have to know what will be to the left of our fulcrum, it will get minus, and what is to the right of our fulcrum, it will get plus, to the weight or to the moment, as you like. Here, if we need to know our fulcrum, our lever is balanced, the total of moment or the sum of moment from A and B must be 0. How can this be? We will answer it now. Here we will answer the moment of A. The moment of A, the first one is minus 10. This is the weight. Multiply our arm, it's 6. It get minus or negative 60. Now we will get B to the right of our fulcrum. It's 10. Multiply 6, it will get 60. So minus 60, because we need the sum of weight, plus 60, it will equal to 0. So when we see that the total of or the sum of moment is 0, so we will know that our lever is balanced. Our lever is balanced. Here in this figure we have a lever and it's in the first class, but here we have the effort. They didn't give us the quantity of effort, and we need to find the effort. Here we have the L, and the L is the arm of the effort, and here we have the I, it's the arm of our resistance or our load, and here we have our load, and they give us the quantity of them. To find our effort, we will make this equation: L divided to I equal to R divided to E. The L, of course, we know it, it's the arm of the effort, and the I, we know it, it's the arm of our load or resistance, equal to the R, it will be the our weight or our load, and the A, it's our effort, and what we are gonna to find it. Here what we are gonna to do, we will take the numerators and multiply by the denominators, and after that we will get the quantity of our effort, and here our effort it will get 14.28 pounds. How can I know if this effort will make the lever balance? We will back and we will take our previous figure as we did. We will take the moment or find the moment. Our moment x, the weight multiply the arm, and we will find the moment over the moment that from the right of the fulcrum and the moment that on the left of our fulcrum. We will start from the left. We will get the minus, and you know why we did that. The weight of the resistance is 100 pounds. Multiply the arm is 0.5. Here, if we do that, we will use our calculation. 0.5 multiply minus 100, it's equal to 50 or minus 50. Now we will calculate the right of the fulcrum. The effort is weighing 14.28. Multiply the arm, it's 3.5. You have to multiply or to make multiplication to find the sum. 14.28 multiply 3.5. We will get this 49.98. Now, if we need to find the moment, we will make the sum for our moments. These we will make sum for them. And here we have minus 50. Sorry, we will have this minus 50 plus 494.98. When we find this, you will find its balance because it's minus 0.02. So our lever is balanced. Here we have the second type of our lever. How we can know that? We will find here we have the fulcrum, resistance, and the effort. And this is the second type. In this second type, an example of this second type, we have the wheelbarrow. And in this second class, we don't care about the balance of the lever. We care about the handle or the effort that will take or gain a mechanical advantage will take the resistance. How can this come? We will take an example. Here we have an example. We have a resistance or load, and this resistance is 200 pounds. And we have the arm of our resistance, it's 12 inch, and we have the length of our effort, and it's 48 inch, but we don't have the effort. We need to find the effort like the previous equation. What we will do, we will make a multiplication between the numerators and the denominators, and after that we will find our effort. When we find our effort, we will take the effort and our load. Our load is 200 divided our effort is 50. It will equal to 4. So our mechanical advantage, it will be 4. It will be 4. So we have here to a force or to effort. In this area we have effort that have 50 pounds to take the load on the wheelbarrow, and that's weight is 200 pounds. So now we get a mechanical advantage. How? We will say we have 50 pound effort to take 200 pound. Here we have the third class of lever. There are events when it's desirable to speed up the movement of the resistance, even though a large amount of effort must be made. The levers that help accomplish this is the third type, as we say here in this figure. The fulcrum is at the end of our lever, and this is our fulcrum. At the weight or the resistance is in the other end, and in the middle we have our effort. We have that like our landing gear. The top of the landing gear, where it attached to the airplane, is the pivot point, and it will be our fulcrum, as we see in this figure. The wheel and the brake assembly, it will be our resistance, and it will be on the bottom of the lever. And our effort, what is the hydraulic actuator that makes the gear is attached or retracted, and its location in the middle. And here we have to more effort to make the speed of the resistance more than. How that's come? When we see here on this figure, we have our load and it's 200 pounds, and the arm of the effort is 0.5, and the arm of our resistance or our wheel is 4 feet. We need to make to find our effort. So we will make the multiplication as usual, and here we will take the denominator, multiply by the numerators to find our effort. Here our effort is 1,600 pounds. We find here our effort is more than our resistance. Why? Because we need to move our resistance more than. An inclined plane is a simple machine that used to raising or to lowering a heavy object by the application of a small force over relatively long distance. For example, when we use to weighing an aircraft or small airplane, we have to get the airplane on the inclined plane or the ramp. And this can be used to get the airplane to the scale. How we can push the airplane by a little force. That's what we will see here in the second figure. Here we have an example of the inclined plane. Here we have our resistance or our weight, and it's 500 pounds. And here they have the L, and the L, it's the length of the inclined plane, and also it's the length of the effort. Also we have the I. How we can find the I? The I, it will be the height of the inclined plane, and it's the arm of the resistance. So here we have the L, it's the length of the inclined plane and the arm of the effort. And we have the I, and the I, it's the arm of the effort, of the resistance, and the height of the inclined plane. Now we will make a cross multiplication, or we will take the numerator and multiply by the denominator to find our effort. And when we make this multiplication, we will find our effort. It's 166.7 pound, and our resistance that you will push, it's 5 pounds. So here we find this difference. We have a little weight to take or to force 5 pounds, and it's bigger than the effort and can make it rise up to this table. A third device that make mechanical advantage, the pulleys. The pulleys are simple machines in the form of wheel mounted on a fixed axis and supported by a frame. The wheel or disc is normally grooved to accommodate a rope, and it's two types, movable and fixed. Here in this figure we have the first type, the single, and here we have our wheel. This it will be like a wheel, and we have a groove between this wheel to support our rope. And here is this type, it's like the first type of our lever. How? We see here the distance or the arm of the R is equal to the arm of the E, and the location of the arm of the resistance and the fulcrum and the effort like the first type or like the first class of a lever. The second type of lever is the movable. Here we have the second type, as we see. And in the single movable pulley can be used to magnifying the force exerted. The pulley is movable. The pulley focus here is movable, and both ropes extending up from the pulley and cheering in the supporting of the weight. This single movable pulley acts like the second lever or the second class of lever. If we see here, we have the both pulley rising up for supporting the weight. And when we see here our fulcrum, it will be in the end. And here our resistance, and here we have our effort, and this like the second class of the lever. The fourth type of mechanical advantage devices are the gears. The gears used to gain the mechanical advantages. Also, it used to change the direction of movement. How that's come? When we see here, we have a drive gear, and here we have the driven gear. To gain the mechanical advantage, the gear's teeth must be doubled in the driven. How that's come? Here we say on the drive gear, for example, we have 50 teeth, and in the driven we have 100 teeth. So when this drive gear will turn 2 times, the driven gear will turn 1 time, and the amount of power required to turn the drive gear will reduce to the half. The second one, how the gears change the direction of movement. If we have external gears like this we have here, we will say the drive gear will turn in counterclockwise, but the driven will turn in clockwise direction. Also, if we want to both turn in the same direction, we need to have internal gear like this. The driven gear will be internal gears that have the teeth from the internal, and the drive gear will be external. When our drive gear will turn in clockwise direction, the driven gear also will turn in the same direction, in clockwise direction. How many types of gears we have? We have 4 types of gear. The first type we called it spar gear. As we see in this figure, this spar gear. How can we distinguish the spar gear from the other types? You will see our gears or our teeth, it will be in parallel to each other. So you will know that if the gears in parallel, that means this is the first type of gears and it's called spar gear. The second type of gears we have it called beveled gear. Beveled gear. If a drive shaft off or if the gears are not in parallel, the beveled gear is used. Like what we have on the tail rotor of the helicopter, if you remember. The helicopter, it has a tail rotor. How this tail rotor will turn? The tail rotor will turn when the main rotor will turn. So you will imagine this connected to the main rotor of our helicopter and this will connect it to the tail rotor. When this will turn, this will turn. So when the main rotor will turn, the rotor will turn with it. The third type of gears that used it called war gear. This gear used when extreme amount of mechanical advantage is needed. And the worm gear consists of a spiral ridge. This is our spiral ridge and it's on a shaft. And here is connected to a drive gear. The last type of gear we have is planetary gear. This planetary gear is used on the propeller shaft of turboprop engine and used for reduce the power that supplied from the engine to the propeller. And this type consists of sunk gear, planetary gear and ring gear.
Whenever machine in operation, be it simple machine such as levers or screws, or complex machine such as aircraft piston engine or hydraulically operated landing gear, they are exposed to something called stress. How that's come? When the landing gear retract or extend, it exposed to force. That force is called stress to make it operate. Or the piston of the engine. How the piston works? The piston works when there is stress on the crankshaft and the crankshaft will rotate and let the piston drive. The definition of stress is the external force that acts on an object and opposed by an internal resistance or force. There are 5 types of the stress and they are tension, compression, torsion, bending and shear. The tension is the force that tends to pull an object apart. What that means? That means when we have an object and we apply a tension force, that means this force tries to make the parts into 2 parts. The second type, compression. The compression is the resistance to an external force that tries to push objects together. Like what you are going to study inshallah in chapter 8, the fastener or hardware. You will study that the hardware tries to make 2 objects together. So this force that applied to our 2 parts from the fastener is called compression. The third type of stress is the torsion. The torsion is a stress that applied to a material when it's twisted. If we need to understand this, you will think about the crankshaft of the engine when it's rotated, so this is torsion stress. Number 4 is the bending. The bending is a combination of two stresses, compression, and that will happen on the upper wing when the aircraft rise, and tension will happen on the lower wing when the aircraft will rise. And the opposite will happen when the aircraft on the ground. If you see, you will see on the lower wing we have a compression stress, and on the upper wing you will find a tension stress. The last type of stress is the shear. The shear stress tries to slice a body apart. What's the meaning of slice? To cut a body apart. And an example of the shear on the aircraft is the cleats of the cable.
There are three laws of motion that explain the effect of force on a matter, and these laws are called Newton laws of motion. Now we will talk about the first law of Newton, and it states that the body at rest tends to remain at rest, and a body in motion tends to remain in motion unless affected or acted on by some outside force. What that mean? We have here this ball. This ball, it will be in its position and it will not move. But if there is a force acted on this ball, it will let it to move, and it will still move in what we say in uniform movement unless there is another object will affect on it and make it stop. This is the first law of motion. The second law, it states that the acceleration produced in a mass by the addition of a given force is directly proportional to the force and inversely to the mass. What that mean? If we have here an acceleration in the force, so we have increase in the force, that will affect on the mass and will decrease our mass. But if we have the opposite, if we have increase in our mass, our force, it will be decreased. The third law of Newton of motion, it states that for every action there is an equal and opposite reaction. An application of the Newton third law is the turbojet engine. The action in it is the turbojet exhaust gases. This will be our action. And the reaction, it will be the thrust that is propelling the aircraft forward. After we talk about Newton laws, we will say what's the difference between the velocity and speed. The difference between the velocity and speed in one thing: the velocity has a direction, it must have as a direction, but the speed, it doesn't care about the direction. And when the velocity has a direction, that's called vector. What's the meaning of vector? The vector is a mathematical expression having both magnitude and direction. The last thing we will talk about it's the circular motion. The circular motion is the movement around a circle. And it has two types: centrifugal force and centripetal force. The centrifugal force is the force that try to make the object leave or leaving the circle. And the centripetal force is the force that tend to remain the object in a circular motion. So the centrifugal force, it's the opposite of the centripetal force.